Good morning to all. My name is T.P. Balaji, Assistant Professor, Department of Mechanical Engineering. Today, I am going to take assignment model in our present research. Assignment model. What is assignment model? Assignment model is one of the special case of transportation problems. The objective is to minimize the cost or time of completing a number of jobs by a number of persons. Single job is assigned to single machine or person. Types of assignment model. There are two types of assignment models. One is balanced types, another one is unbalanced types. If the number of rows is equal to number of columns, that is said to be balanced type. If number of rows are not equal to number of columns, that is said to be unbalanced type. Now I am going to explain Hungarian method for assignment problem. This is the rules for Hungarian method. Phase 1. Row and column reductions. Subtract the minimum value of each row from the entries of that row. Next is column reduction. Subtract the minimum value of each column from the entries of that column. Next is phase 2. Optimization of the problem. Draw a minimum number of lines to cover all the zero entries of the matrix. Procedure. First, we have to do row and column scanning initially. In row scanning, start from the first row. Check that if there is exactly 1 0 in that row. If yes, mark a square around that 0 entry and draw a vertical line passing through that 0. If you found more than 1 0, skip that row. After scanning the last row, check whether all the zeros are covered with lines. Then we have to do column scanning. In column scanning, starting from the first column, check that if there is exactly 1 0 in that column. If yes, mark a square around that 0 entry and draw a horizontal line passing through that 0. If you found more than 1 0, skip that column. After scanning the last column, check whether all the zeros are covered with lines. Next, step 2. Check whether the number of square marked is equal to the number of rows of the matrix. If it is happens, the problem is reached optimal solution. Otherwise, go to step 3. In step 3, identify the minimum value of the undeleted cell values. Next, add the minimum undeleted cell value in the intersecting point of the present matrix. Subtract the minimum undeleted cell value from the unmarked cell values. After completing this, go to step 1. That is, we have to do again row and column scanning. Treat the solution as marked by the squares as the optimal solution. Example problem. This is one problem I am going to explain. First, we have to do row reduction. In row reduction, first we have to do row reduction. In row reduction, we have to identify minimum value in each row. In this slide, see in first row 9 is the minimum value. In second row 8 is the minimum value. Third row also 8 is minimum value. Fourth row 11 is minimum value. And sixth row 9 is minimum value. After identifying the minimum values in each row, subtract the identified values from respective row. So this is the procedure. In first row there is 11, subtract with 9, 2 is coming, and like that we have to do all the procedures. Next we have to go for column reduction. This is the slide for column reduction. In column reduction also we have to identify the minimum values from each column. These are the minimum values in each column. No changes will occur in first column, second column, third and fifth column, because in this column the minimum value is 0. Changes will occur in fourth column only, because the minimum value in fourth column is 2. Then we have to subtract with 2 in fourth column values. This slide shows the final matrix after row and column reduction. Now we have to do row and column scanning simultaneously. First we have to do row scanning. Here we have to check if there is exactly 1 0 in each row. If yes, mark a square around that 0 and draw a vertical line passing through that 0. In second row there is exactly 1 0, so we have to square mark it and pass a vertical line through this 0. In third row we found 2 zeros, so we have to skip that row. In fourth row we found exactly 1 0. You have to follow the same procedure and complete the row scanning. Fifth row there is no zeros. Now we have to go for column scanning. In column scanning, first two rows scanning is completed. Now we have to check the third column. In third column, here only 1 0 is available. So we have to square mark it and pass a horizontal line through this 0. Now row and column scanning is completed. Now we have to check for optimal solution. That is, the number of square marked is equal to the number of row of the matrix. Here in this matrix only 4 square marked is there instead of 5. That is 4 not equal to 5. This slide shows the final matrix after row and column scanning. The next step after row and column scanning is to identify the minimum undeleted cell value from the matrix. In this slide, the matrix shows 1 is the minimum value. In this matrix, 1 is the minimum undeleted cell value. Now we have to add this minimum value at intersecting points, that is 6, 7 and 2. 6 plus 1 7, 7 plus 1 8, 2 plus 1 3. The other vertical and horizontal line marked values are remain same. Now after this we have to subtract the vector with minimum value in unmarked cell. So 7 minus 1 6, 2 minus 1 1, 7 minus 1 6, 5 minus 1 4, 1 minus 1 0, 1 minus 1 0, 7 minus 1, 6. 1 minus 1, 0. Now, row and column scanning is completed. After this, again we have to do row and column scanning. Here, in the first row, we have exactly 1, 0. So, as per procedure, we have square mark around that 0 and draw a vertical line through that 0. In second row also, exactly 1, 0 is there. As per procedure, we have to draw a vertical line. In third row, there is 2 zeros and fourth also 3 zeros. So, we have to skip these 2 rows. In fifth row, here exactly 1, 0 is there. So, we have to square mark around that 0 and draw a vertical line. Now, row scanning is completed. After this, we have to go for column scanning. Already, the first column is marked with line. We have to scan the second column. In second column, exactly 1, 0 is there. So, we have to mark a square around that 0 and draw horizontal line passing through it. In third column also, exactly 1, 0 is there. As per procedure, the same methodology is followed. After row and column scanning, we have to check for optimal solution. That is, number of square marked is equal to the number of row of the matrix. Here, 5 equal to 5 is there. So, the solution is this optimality. Now, we have to show the optimal solution. As per initial problem, in job row wise, we have to check first job, second job, third job, fourth job, fifth job. Here, in first job, fifth operator is locked. In second job, first operator is locked, and in third job, third operator is locked, and in fourth job, second operator is locked, and in fifth job, fourth operator is locked. Here wise, we have given this tabular column, and the expected value from the initial matrix is 8, 7, 7, 10, 11. The total processing time is 43 hours. Thank you.